Next, we'll sketch the graph of a function that has the given limits and function values, and we're going to do a couple of examples of these. And so we're looking here at trying to find a graph where the limit as x approaches negative infinity of the function is 3, and the limit as x approaches positive infinity of the function is negative infinity. So given these two pieces of information, what I like to do first is really think about what each one is telling me about the graph. So here, as x approaches negative infinity, we're really talking about like the left end arrow. So that left arrow approaches y equals 3. See, we saw that when we're talking about going as x goes either to positive or negative infinity, if what we get is a number and not positive or negative infinity, we're talking about a horizontal asymptote. So here, this left-hand limit, we're talking about as we approach negative infinity, we are going to have the function approaching that horizontal asymptote at 3. So we're going to need that arrow to land somewhere there in that circle. As far as the limit as x goes to positive infinity goes, since our answer there for the limit is negative infinity, we're not looking at a horizontal asymptote, but what it does tell us is that the right arrow, because we're talking x going to positive infinity, that would be like the right end arrow, it approaches y, well, maybe we shouldn't say y equals negative infinity, but really when we are talking about limit values, we are talking about y values, or perhaps you might want to think about y directions, so going down forever there without bound. And so what we're talking about is this arrow here that's at the end. X going off to infinity is over here, y going down to infinity, the limit value would be going down on the y-axis. Okay, so that what we have drawn so far is what I like to call the non-negotiables. We have only these things specified based on what we're given in the problem, and now we need to draw a function. Now, functions have to pass the vertical line test, but other than that, we don't have any restrictions. But typically, I like to make things relatively simplistic. And so what I would do is perhaps have here my left-hand arrow landing there in the circle or the oval there that I created, and then connecting it up nice and smoothly to the right end arrow to give us our function f of x. This is not unique. All of you all could come up with different interesting functions, but the non-negotiables were this arrow here on the left had to land or had to be guided by the horizontal asymptote y equals 3, and that the right end arrow over here had to be, as we go off to the right, we had to go down without bound, going down to negative infinity. So that gives us our first example. So let's look at something that gives us a slightly different set of givens. And so here, notice that what we're looking at is a couple of one-sided limits and a function value. We have the limit as x goes to 2 from the left-hand side. That 2 minus is from the left-hand side. And that gives us our value of 2. What that's telling us is from the left, we're approaching, so we'll say approaches. And I'm going to put y equals 2 there just so we remember that that is the value that we're looking at on the y-axis. So y equals 2 is going to be an important value there. Okay. The other one here is the next one here is the limit as x goes to 2 from the positive side. So we're talking about from the right. So from the right, we're approaching y equals negative 1. Okay, so we're talking negative 1 being an important place there on the y-axis. And then the last one is f of 2 is equal to 2. This is a function value. So we're talking about a solid dot at x equals 2 because that's the input value, and y equals 2, that's the output value. Okay, so that is the point 2, 2. Okay. So this 2 here that's on the x-axis, that's our important place. That's our important x value that we're talking about. And so what we found out here is that from the first piece of given, we have that from the left we're approaching y equals 2. So what I'm going to do here is I'm going to draw kind of an extra little place out from the left at the input value 2, output value of 2 also. And then what we have for the second thing is from the right-hand side, we are approaching the value -1. And so from the right-hand side, we're coming here and approaching the -1. Notice there that I have an open circle on the -1 because we already have a function value. It was already dictated. F of 2 is equal to 2, and so I can't do anything. I can't have another solid dot, so I have to make sure I have an open dot there. So what's drawn there is the non-negotiables. We have the solid dot where it's prescribed, and we have the left-hand side coming in to the level of y equals 2, the right-hand side coming in to the level of y equals -1. And so that, whenever I would be grading an answer, would be what I'm looking at as a non-negotiable. After that, the function just has to be a function. It has to pass the vertical line test. And so you've got a lot of wiggle room as to how you want to draw this function. You can make it as complicated as you'd like, but just make sure it is in fact a function. And so that would be one example of a function that satisfies the 3 pieces of information given.